Hello guys, good evening everyone. Please, if you're active, indicate that you're active. If you're active, indicate that you're active. If you're active, indicate that you're active. We shall be starting very soon. If you're looking at pre-calculus, if you're online, indicate that you're online. So we can start. If you're active, indicate that you are active. If you're active, indicate that you are active. If you're active online, please indicate that you're active. If you're active, just indicate that you're active. We are about to start our pre-calculus class. Please indicate that you are active. We are about to start the pre-calculus class. Alright. If you're active, indicate you're present, that you're active. If you're online, indicate that you're online. Alright guys, I want us to have a review on our previous class yesterday. Yesterday we talked about function, which is one of the pre-calculus class. We talked about functions, right? Talked about functions, and we were able to define the concept called function. Then apart from that, we talked about the three major terms that are used in function, where we talked about the domain, the three major terms used in function, the domain, the codomain, and the range. The three major terms that are used in function, which are the domain, the codomain, and the range. And we were able to define them. We also defined the concept functions, right? Then we also talked about the general way of expressing a function, that a function is expressed as f of x, which is equals to y, right? F of x equals to y. F here represents function, s represents the input values, which are also called the permissible values or the independent variable. Y represents the dependent variable. X also represents the domain. Y represents the codomain, right? Then we said F stands for function. F stands for function. And a good example, we'll give an example. If I have f of x equals to 2x plus 4, this simply means y equals to 2x plus 4, right? This is a polynomial function, all right, with a degree of 2. The highest power there is 1, rather, with a degree of 1. The highest power is 1. So it's a polynomial function, but we call this a linear function, right? We can also have a function of this form, which is called quadratic. Like example, we have s squared plus 5s plus 6. This is also a polynomial function. Polynomial functions are grouped into 3. We have what we call the linear function, the quadratic function, and the cubic. Cubic is any function of this kind, like f of s equals s cubed plus 4s squared plus 6s plus 10. This is a cubic function, where the highest power is 3, right? But all of these functions we are seeing here, they are all called polynomial function. Okay, this is just how to represent a function. So for this, we can find the possible values of x for which this function is being defined. Meaning we can find the domain. The possible values of x for which value is being defined can either be 0, 1, 2, 3, or -1, -2, -3. Am I communicating? All right. Because we can be asked to find f of 1, f of 2, f of 3. For example, f of 1 for the first function is simply what? 2 times 1 plus 4, which will give us what here? 6. We can also find f of 0, which is 2 times 0 plus 4, which is equals to 4. Because 2 times 0 is 0, plus 4 will give us 4. So we can find any value of x. We can find any value of x. Whenever we have a polynomial function, it simply means that all real numbers are permissible numbers that can define a polynomial function. All right, let me know what you class. Let me take us step by step so we can understand what I'm saying. But just know that there are three concepts in function: the domain, the codomain, and what the range. All the values of x, like we just saw, values of x represent the domain. Then the values of y represent the codomain. The attributes represent the codomain. The attributes here, we have 6, we have 4. So this represents my y. This is the attribute value, meaning the y value. This is my y value. That means that when x is 1, y is 6. When x is 0, y is what? 4. So it is your input that determines your output. Without the input, we can't get the what? The output. Okay, that's what we call the input, which is x, the independent. Why the output is called the dependent? Because the dependent, y, actually depends on what? On the x value. Okay, then we also have what we call the types of mapping function, or types of function, right? Types of what? Function. And we talked about types of mapping function, which we have one-to-one, right? Also called the injective, right? The injective. We have what we call the onto, which is called surjective. Surjective. We have what we call the bijective, when a function is both. Bijective means when the function is both injective and surjective. All of this we discussed yesterday. You can always go back to my class. Then we have what we call the constant function, constant mapping function, where we say that the value of f of x is equals to k. That no matter the value of the input you have, you maintain the same thing. It's a situation whereby all the permissible values, all the independent values, all the domain are assigned to one particular element in the codomain. All of this we discussed yesterday. The video is still in the YouTube channel. You can always go back and watch. It's called a constant mapping function. For example, if we have f of x equals to 3, it means no matter the value of x, the answer remains 3. If I have f of what? F of 1 is still 3. So f of 2 is still 3. If I have f of 4, the answer is still 3. F of 5 is still 1, 3. We call it a constant mapping function. Then we talked about the composition, right? Composition of function, which we also call composite mapping function, right? Composite mapping function. This is also called function of a function. Function of a function. It's also called function of a function. Composite is also called function of a function. Then we probably have what we call the inverse, right? The inverse mapping function. The inverse mapping what? Function. Then other types of function, like I say, we have the polynomial mapping function, polynomial function rather. We have what we call the rational function. Rational function is of this type: f of x equals to gx over hx, where we have both the numerator and the denominator being a polynomial, meaning that the numerator and what denominator are both what polynomial. A good example of that can be, let's say, f of x equals to 2x plus 4 over, let's say, x minus 5. This is called a rational what? A rational function. All right. Then we also have other functions. So we have dealt with all of this yesterday. So today our aim will be on how to find the domain of a function. The domain of a function. No function can be fully described without knowing the domain. We can't be able to evaluate a graph or a function without knowing the permissible values that can define that function. I'm going to explain, all right? Please, if you're online, share the link to others. Let them join. We have started. If you're online, just share the link to others. Let them join. If you're online, just share the link to others to join. Please check the link. We have started. We have started. We are behind time. Okay, so let's proceed. One of the most important concepts you must take note of in function is called the domain. Very most important because it is the domain that describes a function. We can't be able to evaluate a function or evaluate a graph without knowing the possible values of x that can actually describe or explain that graph. We can't be able to fully evaluate a graph or construct a graph without knowing the values of x that can define that function. That's why your domain is very important. So when we say domain, our topic for today, the first topic we'll look at under function is called domain, right? Domain, domain of a function, domain of, of a function. How to find domain of a function. In most cases, yesterday we talked about mapping function where we have our domain and we are given a function. What we need to do is just to find the dependent variable, right? The attributes. Is that not? Then what do? We have to map. Now there are some cases whereby the domain is not given, but you'll be given a function and you'll be asked to evaluate or find the domain of that function. We can find the domain of a polynomial. Like I've already explained that polynomial is of three types. We have the linear function, which which is the case where the value of x, the power, right? The highest power in x is 1. Number 2, we have the quadratic, in which the highest power is 2. We have the cubic, in which the highest power is 3. These three, they are classified as what? Polynomial. And we can find the domain of a polynomial. So once you hear the word polynomial, what comes to your mind is linear, quadratic, and what? And cubic. We can find the domain of a rational function. Like I gave you a rational function. If I have f of x, which is hx over what? Gx, can also be gx over what? Hx. All right, where gs and hs are polynomial, right? We call this the rational what? Function. We can be asked to find the domain. When you hear the word domain, it means what are the permissible values of x that can define this function. Not all values of x can define a function. Not all values of x can define a function. Now you now understand what I mean by the word domain. So when you hear the word domain simply means x. So if I have a function, let's say f of x equals to 2x plus 4. Okay, and we're asked to find the domain of this. The domain of this. Let's look at this together. The permissible values, what are the possible values of x that can define this function? Meaning that, what are the values of x that I can substitute into this function that will give me a value of y? You get the concept here? Okay, that will give me a defined answer. A defined answer. Your answer can either be defined or undefined. Okay, when we get to rational, I will explain the concept undefined, and that is where I'll be able to explain to us that not all values of s is permissible under rational function. So for this, if we are to find the domain here is just all real numbers, which implies negative infinity to positive infinity. I'm going to explain. If you look at this f of s equals to this, it means that I can substitute my 0, and that will give me 4, right? I can substitute my 1, that will give me what? 6. How do we get 6? 2 times 1 is 2. 2 plus 4 is what? 6. If x is 0, it means that 2 times 0 is what? 0. 0 plus 4 is what? 4. I can put the value of x as 2. That will give us what? 2 times 2 is what? 4, right? 4 plus 4 is what? Is 8. Are you there? No matter what the values of x is, I can find what? Y. Don't forget that f of s represents what again? Represents your y. Is that not somebody? It means that there are all real numbers are permissible to define the function, to define this function. There's no value of x that we cannot substitute, whether it's 0 point, whether it's 1 point, whether it's minus, whether it's, do you get the concept? So if you look at your number line, the center number is 0, right? So it means that for us to define our domain, I have to use a number line to explain it. Number line shows numbers from 0 to negative infinity, right? And to what, yeah? Positive what? Infinity. In fact, number line shows all real numbers. All real numbers can be captured on a number line. What are real numbers? For example, -1, -2, 0, 1, 2, 3, 4, 5, 1 over 2, okay? -1 over 2. Fractions are real numbers. Am I communicating here? So, if you look at this now, I can capture all of this number on a number line. So it simply means that we cannot keep on putting the values of x. I can't keep on saying when f is what? Is 3. When f is 4, because I want to find the domain. Domain means x. I hope you're aware. So we cannot keep on doing this. Since we have a polynomial, which is a linear function, it simply means that the domain is simply what? All real numbers, which is what? From negative infinity to what? Positive infinity. All real numbers comprise of what? Yeah? It means from this point 0 down to this point, yeah? Then from here to here. Exactly. So it means that all the permissible numbers that can define these functions includes what? All real numbers. I don't know if that is clear. So you must have to take note that for all polynomial, the domain of all polynomial is what? Somebody? Real numbers. The domain of all polynomial are real numbers, and which can be written as what? Minus infinity, comma, to what? Positive what? Infinity. It means that the permissible values of x that can define every polynomial, such as this, is simply from negative infinity. Like I can say, even if we keep on using -1, -2, -3, -4, -5 to negative infinity. Negative infinity means from negative, from here, we have -1, -2 to -3, down to this point. If I keep on substituting values of x, all the values of x, and that of y, okay, all of these numbers are permissible, meaning they can define what? Our f of x. So that means my domain of all polynomial includes what? All real numbers, which is what? Negative infinity to what? Positive infinity. Even if I have this, let's say we are giving f of x to equals to x squared plus 5x plus 6. Plus 6. Are we there? So, and we have to find the domain of this. There's no need of solving this. For those of you who attend UNN, you don't need to solve. Once you see a polynomial function, this is a quadratic equation, which is also a good example of what? A polynomial function. Once you see this and you have to find the domain, the answer includes what? All real what? Numbers. And which includes what? Minus infinity to what? Positive what? Somebody? Infinity. Even if you are given this, let's say, let me give you an instance. Let's say we have this, we have f of x equals to x cubed plus 4x squared plus 6x plus 7. And it said, find the domain of this function. The highest power, this is a polynomial function. There's no need of solving. Just know that the domain of all polynomial, the domain simply includes what? Minus infinity to what? Positive what? Infinity. It means the permissible numbers that can define these functions are number from 0 to what? Infinity. From 0 to what? Positive what? Infinity. Are you there, somebody? So this symbol here means from negative infinity to what? Positive infinity, including 0. Including 0. So if I'm to bring out these numbers between these, it means negative infinity, let's say -5, -4, -3, -2, -1, 0. 1, 2, 3, 4, 5. So positive what? Infinity. Am I communicating here? Okay. Or let me see how I can represent this in a set. If I have minus, let's say we have minus dot dot dots. Okay. Then we have let's say we have, let me use numbers. There's no way you can even express it. So the only way is just to express it this way. I'm trying to see how I can illustrate. Or let me try and see a minus, let's see -1. But before this, it must be dot dot dot, right? Let's see -1, -2, -3, and 0. Am I communicating? No, let's go this way. -3, -2, -1, 0. Okay. 1, 2, and 3, dot, dot, dot. This dot, dot, dot means that there are other numbers, right? This way. Is that not? This means there are also the other numbers which are positive. So this simply means negative infinity, right? It means negative what? Infinity to what? Positive what? Yeah, infinity. Just take note. In anyhow you want to explain this, all we just know is that whenever it involves a polynomial function, the domain is always real numbers, which includes negative infinity to positive what? Infinity. All right. Please, if you are following, indicate in the comment section that you are following. Indicate in the comment section that you are following. Indicate that. Okay. So let's finish up. Let's look at domain of rational function. Of rational function. Domain of rational function. Not all values of s that are permissible. Please, if you are following, indicate in the comment section you are following. Please indicate. Please indicate in the comment section. Okay, we're going to continue. Let's look at domain of rational function. Please permit me a little. All right, let's see an example. Let's look at domain of rational function. What actually defines a rational function is that if we are given f of x equals to h of x over g of x, okay, you must have to take note that g of x must not be equal to what? 0. For this to be a rational what? Function, g of x must not be equal to 0, meaning that the denominator must not be equal to what? To 0. Are we there? So let's say we are given a distance. Example, if we have f of x equals to 5 divided by x minus 2, and we have to find the domain. Find the what? The domain of this function. Domain in this case means what are the permissible values of x, right? That can define this function. Like I said, not all values of s can define a function, but for polynomial, all values of s can define. There are some certain functions that not all values of s can define them. Now, for this case now, the value of s that can define this function we are looking for, right? So what do is that we have to set the denominator to be equal to 0. It means that I will set solution to this. We have to set the denominator to be equals to what? Equals to 0. What does that mean? For this not to be equals to 0, denominator not to be equal to what? To 0. What we mean here is that because we say that f of x equals to h of x divided by g of x, some textbooks they will say equals to 0. All they are doing is just to find the value of s that will not define that function. Or the best way is that just set it not to be equal to 0. Because if g of s is equal to 0, that means f of s becomes undefined. Are we there? For example, if I have a function like this, f of x equals to, let's say, 2 over 0, f of x equals to, let's say, s plus 4 over 0. These are undefined function. Undefined function. Exactly. By the time you punch calculator to divide 2 by 0, you have a mathematical error or undefined. Are we there? So the best way is that to define a rational function is that we have to set the denominator, which is g of s, not equals to 0. So let's go. Let's see what we are going to obtain here. By the time we set this as x minus 2 not equals to what? To 0. All right. So what do we do to find the value of x? I have to move this right to the other side, or we add 2 to both sides. By the time we add 2 here, we add 2 here. Here will give us what? X if not equals to what? To 2. Or the best way we all know is that we move minus 2 to the other side, right? The result becomes what? X. That means that the values of x that can define f of x are all real numbers except what? 2. They are all real numbers except 2. Why do we say except 2? If you look at this here, we have f of x equals to 5 over x minus 2. What is that value of x that once you substitute the value of x in this function will give you undefined function or undefined answer is the value of x as 2. So when you put 2 here, what do you have? 2 minus 2, that will give us 5 over what? 0. That gives us what? Undefined. So that means that our domain includes all values of x apart from what? Apart from 2. Now let's see how we can do that. Let's do that together. Here we have 0, right? Here we have what? Here we have 2. Now that simply implies that all the values of x on this number line are minus 1, right? Minus 2, minus 3. So minus what? Infinity. Here we have what? Here 1. We have what? 2. We have 3. And we have what? Plus what? Infinity. It simply means all the values of what? Of x apart from this. Apart from this. Apart from this. So what do we do? The domain becomes what? Here becomes from negative infinity, right? Negative infinity, comma 2. Union 2, comma positive infinity. This simply means negative infinity, comma 2, then from 2 to what? Positive what? Infinity. There are some certain signs you must have to take notes in domain. Anytime you see a bracket like this, it simply means that that value of s is not included. If I have a bracket like this, it simply means the value of s is what is included. This symbol here means, this bracket means we are excluding the value of what? Of x, of 2. Are you there? So we have seen that the domain simply implies all the values of x apart from what? From 2. And this is how it's being written. Minus infinity to that 2. Alright? This bracket simply means we are not including 2. If I have a bracket like this, let's say this is what we have here. This simply means I'm including the value of 2. Are you there? So the domain here becomes what here? Minus infinity down to what? to 2, then from 2 down to what? Positive or somebody, infinity. Some people call this union. It means we are combining. It simply means union. We're combining all the permissible values of s that can define this function here to be from negative infinity to what 2, then from that same 2 to positive what? Infinity. Okay, that's the first example. Let's see example 2. Example 2 says, if we are given, find the domain of f of x. Find the domain of f of x equals 1 divided by x minus 4. This is also almost similar with the first example we just saw. Okay. So what do? We have to set, right? Set the denominator not equal to 0. Not equal to 0. Meaning x minus 4 must not be equal to 0. So that means x is not equal to what? To 4. So that means that the value of x that are permissible in these functions are all real numbers except what? 4. So from the number line, it simply means the result becomes, here we have 0, right? We have 4. We have 5 here. We have 6. We have 7. It means I will circle this 4. It means down to positive infinity, right? Here we have minus 1, minus 2, down to negative 1 infinity. It means all these numbers here, apart from what? From 4. So that means, how do we write this now? The domain becomes what? Minus infinity to 4. Then our union, we have 4 to what? Positive what? Infinity. From negative infinity to that 4, but we are excluding 4, right? Then from 4 to what? Positive what? Infinity. Okay. Example 2 or 3. Find the domain of x plus 1 of fx equals x plus 1 divided by x squared minus 9. X squared minus 9. The same thing we did here. We have to set this, right? To find the value of s, we have to set this x squared minus 9 not equals to what? 0. So what do we do here is to factorize. We have to factorize this to find x. Factorize to find x. To find x. When you factorize this to find x, that means we have our x squared minus what? 3 squared not equals to what? 0. Don't forget. There's a rule called difference of 2 squared. If we have a squared minus b squared, the rule says what here? A plus b times what? A minus b. That's the rule. It's called difference of 2 squared. So I'm going to apply it here. Here becomes what? S plus 3 times s minus 3 not equals to what? 0. So this simply means our x is not equals to what? When you move this, okay, let me bring out this. This simply means s plus 3 not equals to 0 or x minus 3 not equals to 0. What does that mean? X is not equals to minus 3 or x is not equals to what? 3. Now, what does that imply? This implies that our domain are all possible values of x except what? Minus 3 and what? And 3. Except minus 3 and 3. So let's see how we can get that to the number line. Here we have what? Here we have 0. Here we can generate minus 3 from here, right? This is negative side. We can generate what here? Plus 3 from here. Then other numbers here becomes what here? This is negative infinity. We have minus 2. We have minus 4 rather. We have minus 5 to negative infinity. Here we can have 4 here. We can have 5 to what? Positive what? Infinity. So our domain includes all the values of x except these two. Except this and this. Except this and this. Minus this. The values of x except what? Minus 3 and what? And 3. It means I will include all this number, also include all this number, then exclude the number between minus 3 and what? And 3. Am I communicating here? Okay, let's see what we want to generate. So the domain becomes, from here we have minus infinity to minus 3. Then from union minus 3, comma, from minus 3 to what? To 3. Union 3 to positive infinity. Am I communicating? So minus infinity to minus 3, which is this. Then minus 3 to what? To 3, which is this. Then from that same 3 to what? Positive what? Infinity. So this is my domain of this function. These are the permissible values of x that can define the function, apart from minus 3 and what? And 3. You can see that we included them here, minus 3 and what? And 3. So this is the domain of this function. I hope we are following. Now let's see other example. If we have a square root function, or let's say even square root, if we have a function like this, find the domain of this. Find the domain of f of x equals square root of x minus 5. The domain of root of x minus 5. Now, whenever I have an even square root, like root 2 root a, 4 root a, 6 root what? A, 8 root what? A. We have to set the polynomial inside the function to be greater than or equals to 0. Whenever you have an even function, this is an even function. Square root means 2 square root. It means it's an even square root. 4 is an even square root. 4th root, 6th root, 8th root. Then. So when you have an even function like this, we have to set the word polynomial inside the root to be greater than or equals to 0. So for this, solution to this becomes what? I'm going to set this s minus 5 to be greater than or equals to what? 0. So when you move this to this side, it becomes x is greater than or equals to what? 5. So that means that our domain, the domain will be all values of what? Of x that start from 5 down to what? Positive infinity. X greater than or equals to 5 means what are the numbers greater than or equal to 5? One is that 5 itself is included, 6 is included, 7, 8, 9, 10, 11, 12. So down to positive infinity. So from the number line, if I have 0 and I have 5, it means that from this point here down to this point are the numbers. This is positive what? Infinity. So all these numbers here are not included. Numbers that are included in the domain are simply from 5 to what? So positive infinity. Are we there? Now let's see how we can bring on a domain. So that will give us what here? 5. Domain becomes 5, comma, positive infinity. Now are you seeing the way I represented my 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 bracket? This bracket here shows that 5 is included. We are not excluding 5. We are including 5 as part of the word domain. Are you there? Then down to positive word infinity. If we have this kind of brackets, 5 comma this simply means that 5 is not included. So be careful in the exam. But we're giving these two options, and we have s is greater than or equals to what? 5. So the permissible values of x that can define the function is simply this, not this. Because we are told that in the function that we have to set the polynomial to be greater than or equals to what? 0. And that gives us s is greater than or equals to 5. So 5 is part of the function, part of the domain, right? So we have 5 comma infinity. Okay. Let's see another example. If we are given this, we are given f of x to be equals to 2x plus 8. We have to find a domain of this. The same thing we did here. This is an even square root, right, function. So we have to set the polynomial, which is 2x plus 8 greater than or equals to what? 0, right? Here becomes 2s greater than or equals to, when you move this, here becomes minus 8, right? So divide both sides by 2. To find the value of x, I'll divide both sides by 2, by what? By 2. So 2 cancel 2. We have x is greater than or equals to minus 4. Are we there? Okay. So this simply means the numbers that are greater than or equals to minus 4, all right? But minus 4 is also included. Are we there? Minus 4 is also included. Let's see our number line. Let's see our number line. We have here to be 0, right? Yes, let's say minus 4 is here. That means from this region here, we are going this way. Greater than means to the right. Is that clear? So numbers greater than minus 4 are numbers from this greater than or equal to minus 4, meaning from minus 4 down to positive infinity. Other numbers here, we have like minus 5, minus 6. These numbers are not greater than minus 4. I hope you are aware. So numbers greater than minus 4 are simply from minus 4 towards the right, right? So that means our domain becomes minus 4 is included, right? Because I have an equal sign here. Minus 4, comma, positive what? Infinity. Please put this up. Minus 4, comma, positive infinity. Okay, so let's proceed. Let's proceed. The next question we have here says, Find the domain of f of x equals root 9 minus x. Okay, 9 minus x. Now, if you are given this, what we do here is that we have to set the polynomial to be greater than or equals to 0, right? Okay, you also have to say 9 minus x is greater than or equals to 0, right? So what do we do next is to make our x a subject. So I can move this 9 to this side. I have minus x is greater than or equals to 9, minus 9, right? Now look at this now. Whenever you are dividing by, we have x here, and I want to divide by minus to make x as a subject in the formula. I have to change my sign. If I have greater than or equals to, the sign becomes what? Less than or equals to. Or if I have greater than, it becomes what? Less than. What I mean is this. Let's divide and see. Divide both sides, Abi. Both sides by what? By minus 1. For us to find x, I have to divide both sides by minus 1. So here becomes, sorry, here becomes minus x is less than or equals to minus 9 divided by minus 1 divided by what? Minus 1. The reason why we are doing that is because we are dividing both sides by what? By minus 1. Even if I have minus 2x here, I will do the same thing. If I have minus 3x, I will do the same thing. But if I have only positive x, the sign remains the same. Like in the previous example we did under even square root, the first and second, you can see that the sign remains the same. But for this, because I have a negative sign here, and I want to remove this minus sign, this sign will have to inverse itself. So here becomes our x is less than or equals to what? 9. Less than or equals to 9, right? Less than or equals to 9. So it simply means our range are, let's bring out our value. Here we have 9. The number less than or equals to 9 is from this, right? From this region here, down to what? To 9. So the domain becomes negative infinity, right? To 9 itself. To 9 itself. But in this case, 9 is included. So I will use this kind of bracket, right? To illustrate that 9 is part of the domain. But it's from negative infinity towards somebody to 9. Because we are told that it is less than or equals to 9. Okay. Let's see more example. We are about to end this part, so we can move down to other aspects. All right. Let's see this example we have there. Here we have I want us to take note of something very important from this note that we can proceed. Now, please take note that, we say that when the value of n is even, like for example, if I have 2 root a, 4 root a, right, 6 root a, we say that we have to set a, right, to be greater than or equal to 0. But when the value of n, all of these represent n, right there, all of this simply means n with what? A. Where n can be what? Can be 2, 4, 6, and 8, right? But if my n is odd, it simply means my range, the domain rather, it means our domain includes all real numbers, which are what? Minus infinity to what? Positive what? Infinity. A good example, if I have third root of, let's say, s plus 4, are we there? If I have fifth root of a, seven roots of a, ninth root of what? A. As long as the value of n here represent odd number, the domain is simply all real numbers. Please take note. But when the value of n is even number, we have to set the value of a to be greater than or equal to what? 0. Don't forget. Take note. That just came to my mind. So let me just clear that. Now let's solve a problem. This problem says that find the domain of f of x to be equals to 3x minus 8 divided by s squared minus 9x plus 20. Okay, looking at this, before you start solving, you have to look out for the function given. What kind of function was given? We are given a rational function where we have to set the denominator not to be equal to 0, right? So like I say, solution to this, we have to set this. We say s squared minus 9x plus 20 is not equal to 0. Are we there? It's not equal to what? To 0. So what do we do here? We have to factorize, right? We have to factorize. We factorize the expression. Now, how do you factorize the expression? We bring out the first term, right? And the last term. The first term here is s squared. Last term is 20. So multiply the first term with the last term. That will give us 20 s squared. I want to believe we all know how to factorize a quadratic expression, right? So the first term and the last term, when you multiply them, we have 20 s squared. We have to think of two numbers that when you multiply them, the result must be 20 s squared. But when you add them or subtract, the result must be minus 9x. That should be minus 5x and minus 4x, right? Minus 5x times minus 4x is 20x squared. Minus 5x minus 4x is what? Minus 9x. Two numbers, when you multiply them, the result must give us 20x squared, which is the product of the first and last term. But when you add them together, the result must give us the middle number here, which is what? Minus what? 9x. So those two numbers are simply minus 5x minus 4x. Let's take that again. Minus 5x minus 4x is minus 9x. Minus 5x times minus 4x is what? Plus 20x squared. So it means that I'm going to replace these two numbers now with minus 9x. That will give us what here? S squared minus 5x minus 4x plus 20 not equals to what? 0. So let's factorize this. Between this is what is common is x, right? So if s is common, divide this s squared here. Here we have s squared. If s is common between them, divide this s squared by x. We're going to be left with x here. Divide minus 5x with this x. Minus 5x with x. We'll be having what here? Minus 5. We are done with this. Then between these two, what is common is minus 4 is common, right? In bracket, divide minus 4x with minus 4. That will give us x here. Are we there? Then divide this 20 by minus 4. That will give us minus 5. Not equals to 0. Let's take this out and see. S times s is s squared. S times minus 5 is what? Minus 5x. Minus 4 times s is what? Minus 4x. Minus 4 times minus 5 is what? Is 20. Anytime you are factorizing, anything you have in this bracket must appear in this other bracket. So if you can get this bracket correctly, you can be able to know what is here. All you just need to do is that once you get to this point here, between these two, what is common is minus 4. Bring it out and bring out what you have in this bracket. Then you can test like I did. Minus 4 times s is minus 4s. Minus 4 times minus 5 is what? Is plus 20. But not equals to 0. Therefore, this simply means x minus 4 and x minus 5 not equals to 0. So by the time we proceed here, this implies x is not equals to what? 4, or x is not equals to what? Somebody? 5. Now, what are the range of this value? What are the domain rather of this value? The domain of this value are all values of x apart from 4 and what? And 5. The domain of these values, the permissible values of x that can define this function, the permissible values of x, permissible values of x that can define f of x, this function includes all real numbers, right? Except 4 and what? 5. So let's see how we can bring them out. Let's see how we can bring them out. So let's go. So if I have my number line here we have 0. Here we have 4. And we have what? 5. So the numbers we are excluding is these two, right? We are excluding these two. So that means we are adding up all these numbers. We're adding up all these numbers, right? Here we have negative infinity. Here is what? Positive or infinity. So that means that our domain will be what? Our domain is going to be minus infinity to 4 union 4 to 5 union 5 to positive infinity. Yes, minus infinity to this 4 here, from here to here, right? So that means from this to this, we are excluding this, which is this, right? Then from that same 5 to what? Positive infinity. This represents our domain. This represents our domain, all right? This represents our domain. We have a past question here that says that find the domain of f of x, the domain of f of x, which is equals to square root of x minus 4. This is just under even square root function. Okay, what we do here just to say solution to this, I've already taught us already. We say x minus 4 is greater than or equals to 0. That means our x is greater than or equals to what? 4. It means that the numbers in the number line, okay, are greater than 4, right? 4, 5, 6, 7, 8 to positive infinity. All these numbers are what? Excluded. They are not part of the domain. So that means from 4 to positive infinity. But also that 4 is included. So that means my domain becomes what? 4, comma, positive infinity. Are we there? 4, comma, positive infinity. Another example. We have a function that says f of x is equals to square root of x minus 4 divided by x squared minus 25. We also find the domain and the code and the domain of this function. In this case here, we have what we call the rational function, but in the numerator we have a square root and even square root function, right? The first thing we need to do is to apply this first. We have to set this to be greater than or equal to what? 0. We set the numerator to be greater than or equal to 0, meaning x minus 4 is greater than or equal to 0. So that means our x is greater than or equal to what? 4. Are we there? That's the value of the first one. Let me call this equation 1. Then we also set this. This is also a rational function. So we have to set this not to be equal to what? 0. We set the denominator not to be equal to 0, right? So that means that we have x squared minus 25 not equals to 0. Are we there? So from here, we're going to have here x squared minus 5 squared not equals to 0. We're going to factorize using difference of 2 squared. Difference of what? 2 squared, right? We factorize using difference of 2 squared. Let's see what we're going to generate here. This will give us x plus 5 and x minus 5 not equals to what? 0. So from here we have x is not equals to what? When you move this here, this means x plus 5 not equals to 0 or x minus 5 not equals to what? 0. So here we have x is not equals to minus 5 or x is not equals to 5. But let's determine what will be the range, the domain of this function. The first one says s is greater than or equals to 4. So let's say we have here as 0, here we have here as 4. The second one says s is what? 5, right? Then the third one says x is minus 5. Are we there? X is minus 5. Let's look at this. The values of x that can define this function. The first says x is greater than, meaning from this, right, towards this direction. Are we there? Okay. So that means that our permissible values of x that can define this function simply includes all the values of x from 4 to what? To positive what? Infinity. Excluding minus 5 from 4 to positive infinity. Excluding minus 5, of course, from 4 to positive infinity. Whenever you have a case like this, or we have s is not equals to minus 5 or s is equals to what? To 5. Don't forget that we have here as s is greater than or equals to what? 4. Meaning from this 4 greater than towards this side. It means it covers both this 5, right? But excluding what? Minus 5. Are you there, somebody? If I'm coming this way, if I'm coming this way, this is very wrong, rather. We can't determine our domain this way. Since this function is saying that x is greater than, that means I will start from here and include every other values of x on this side. So let's see what we can generate. That means it will be from 4. Our domain becomes what? From 4. Okay, let's check this out. 4 is included, right? 4 is included because here says x is greater than or equals to 4. That means we have 4 being included. We have 4, comma, then 2 from 4 to 5. Is 5 included? Here we are saying 5. X is not equal to 5. That means 5 is not included because on this side we have 5, right? 5 is not included. Are we there? So that means I'm going to use this bracket. Then we have union. So from that same 5 that is not included to what? Positive what? Infinity. This is our domain. Domain is simply from 4 to 5 then from 5 to what? Positive infinity. Okay.